We're going to look at one more extended example in the last part of this lecture to introduce again some new ideas around using classes. But before we do, let's take a second to step back and talk about why. What's the power of object-oriented programming? Why would we like to do this? We've already said some of this earlier, but it's useful to remind you of this. The first idea is that we want to bundle together objects that share some common properties. They share common attributes, and they share procedures that operate on those attributes. That's an abstraction, and it's a really nice abstraction because it lets us make a distinction between how to implement the object and how to use it. Defining the class lets me define the methods. That tells me how I want to use that object. When I actually go to use it, though, I can simply use the instances and use that associated or inherited methods along with them. The second thing that object-oriented programming gives us, this idea of bundling things together, is another idea of abstraction, which is I can treat each instance of that kind of class, that kind of object, as if it's a primitive. I don't have to think about the internal representation. I don't have to think about the details of how to get at it. I simply know that there are a set of methods associated with it. And that lets us then build on top of that idea. And in particular, it lets us build layers of abstractions that are going to inherit from other classes of objects. We're going to come to that idea in a second when we talk about not only having classes, but having inherited classes, classes and superclasses and other superclasses, or a better way of saying it, some base level of class and sets of subclasses underneath it that inherit behaviors from classes above them in the hierarchy. And that's what we've been doing already when we build our own class of objects on top of Python objects. We're inheriting the base methods for printing, for accessing elements of lists on top of those Python objects, and we're building on top of that directly. We have already talked about this idea, but I want to remind you again that we want to distinguish between implementing the class and using the class. And when you think about it, I'm really writing code from two different perspectives. I'm thinking about how do I implement a new object type. There I define the class, I define the data attributes, what is the object, and I define the methods. How do I want to use the object? And I do that before I ever have a particular version of it around, so that when I use the class, I can simply create instances and just use the operations, again, without thinking about what's inside of them. One last way of thinking about this, I've got a class definition of an object type. I want to distinguish that from the instance of it. So a class is the type itself. When I created coordinate, it was a class type. And the class is defined generically. I use self to refer to any instance while defining the actual class. And that class defines the data and methods that are common to all instances of the class. Separate from that is when I actually create instances of the object, I have a particular version of the object. My coordinate, for example, is a particular coordinate. And nice thing here is that I can have many different instances. They have different values. They are different because they have different values, but they all have the same structure of the class. They all use the same common methods. And so I'm going to keep flipping back and forth between defining the class and the behaviors associated with all instances of the class from particular uses of that on unique and specific instances. Okay, with that in mind, let's do one last slightly larger example. And this is going to try and get us at the idea of why would we want to have classes of objects anyway, other than this notion of bundling things together. And part of it is we might want to mimic actual systems. So different kinds of objects are all parts of the same type. So I might have different cats. Jelly, a 1-year-old brown cat. Tiger, a 2-year-old brown cat. Bean, who's very young and is black. And I might have different instances of rabbits. But I've already said that both of these can be clustered together because there are behaviors that belong to cats and there are behaviors that belong to rabbits. And I'd like to have classes capture those common behaviors so that I can build instances of them that can have those behaviors but also have other kinds of attributes. Let's see what happens if we wanted to build that out. So I need to think about what are the data attributes and what are the procedural attributes. And this is just recapping what we've done before. The data attributes, how do I represent our object with data? And well, as everything so far we've done has been numerical, I can start thinking about other kinds of things. For an animal, it might be an age, which is a number, but also a name. What are the procedural attributes I want to have? Again, I did numerical things when I was talking about things like coordinates, But for things like animals, I might want to have methods that do other things, like have it make a sound. This is letting me generalize what attributes, procedural attributes could do. And that's going to make sense as we actually start building the animal. So let's do that. I'm going to start with the notion of an animal. It's going to inherit from object, as we've already done, or as we've done in every other case so far. We're going to do a variation of that in just a second. As I've also done in every case so far, I need to define an init method that's going to create instances of the animal class. So there's the class definition, there's the name, there's the parent, there's the special method to call the instance, and there's, again, as before, the variable that's going to refer to the instance of the class, and there's the other information I want to pass in. In my case, every animal is going to have an age, even if it starts at 0. The other thing I can do here is that I can define not only bindings for data attributes that are passed in this case age, but I can also define data attributes that I'm just going to set up internally, that I'm going to set separately. And in this case, name is not something I pass in, but this init is going to create a binding for both age and name inside every instance. And initially, name is simply set to none. Newborn animal, it doesn't have a name yet. I get to name it. Point I want to make here is that I can define other data attributes that I want to use even if I don't pass them in as initial parameters when I create instances of that class. There's the first start on animal. Okay, so I could make one of these things. I could say my animal is an instance of animal, and I need to give it an age, and that lets me now use animal in ways like saying what's, for example, the binding for age or the binding for name. Particular instance, particular parameter passed in that's mapped in that particular instance to that class definition variable. All right, let's start doing some interesting things with animals. I did this a little bit earlier. I said I need methods to get out values. And here I'm going to have something that gets out the age, something that gets out the name. That makes sense because those were the two attributes I defined up here, even though I didn't pass in an initial value for name. But I also want to have another kind of method here, and we call those setters. And those are methods that can change the binding for internal data attributes. So if I want to change the age, if I want to run a simulation, the animal's getting older, I can change the binding for age. I can rebind it to a new value. I could also change the name. It starts out as none, and I could change the name by having a rebinding here. And my version of setting the name is going to use something we've seen before, which is not only the name of the variable, but I'm going to have a default binding, which is the empty string. So that if I call setName on an instance, if I don't give it an argument, I'm just going to redefine it to be the empty string, or a string of nothing, as opposed to that separate symbol none. And of course, I could pass it in as a particular name, which I'm going to do in a second. And finally, as I've done before, I'm going to want to have a way of printing out what an animal is. And here, my choice is going to be the string of animal with a colon, followed by the actual name of the animal, followed by its age, so that I can tell some information about that particular instance. I've just added some more methods to an animal. I want to remind you again that those getters and setters should always be used outside of the class to access the data attributes. So let's try this out. Let's go over and load up animal. I've done that, and let's see if we can give a particular example of that. So my animal is an animal, and it takes in an age, and I'm going to say it's 3 years old. And if I print my animal, it does what I asked it to do. It gives me a string that says it's a version of an animal. It has no name, none, and its age is 3. Well, I'd really like to give it a name. So I could say my animal, and I want to set the name. And I'm going to, I don't know, pick a particular name, the standard computer science name, foobar. And now if I print my animal, it says it's an animal, it's got the name foobar, and it's 3 years old. Now, I want to come back to this idea of always using the getters and setters outside. Again, I could use getter on this. I could say my animal, and I want to get its age. And it says it's 3, which makes sense. That's what I put in there. But let's go back to this idea. this is just going to remind us again of what we already know. I can create an instance by using the class definition. The dot notation lets me get out the pieces inside of it. And I could, in principle, get my animal's age. Again, if I type that in here, my animal age. But in fact, I really don't want to do that. I'd really rather use the getter. And that's because I want to separate the internal representation from access to that representation. And so here I'm directly accessing the data attribute. Here I'm using the method and calling it in order to get it out. And this is much better because it's going to separate out things outside of the attribute from things inside of the attribute. And in fact, that's what we call information hiding. We can actually use it in other ways. I could define a definition and change the name of a data attribute. Here, I've decided to have have init define years to hold the value of age. I'm replacing the age data with a use of the name years. And I can make that be okay by simply changing the getter so that it refers to that piece. This leads to this important high-level issue, which is when you're accessing data attributes outside of the classes, you should always use the getters. If you're doing that access directly outside of the class and the class definition changes, I can get errors. In this case, I changed my class definition to use years as the name for age. And so if I try and get a.age and I've made that change, I'll get an error. Whereas if I use the getter and I've changed it, this will always work well. So I really encourage you to be clean and crisp about using getters outside of instances to get out the pieces internal to them. Unfortunately, Python doesn't enforce this. Python's not great at information hiding. It lets you, as we just saw, go in and directly get access to those pieces. I could also write into an instance something like its age is infinite or its size is tiny. While I could do it, please don't. It's not good style. Always write a method to store new attributes inside of it, to access using getters the attribute values that you want out there. Even though Python would let you shortcut it, you're much better off writing code that always is clearly using specific methods to get to attribute values. Okay, this is just repeating what we already knew, and I'm simply going to do it one more time. Self is always determined from the instance. We pass it in as an argument. We did that, for example, with an initialization method. But when we call a particular instance, that's provided automatically. And that's why when I use animal, I simply give the age. I don't use a specific call to the instance. I do have another way, as we've seen, of getting to it. So there's using the method associated with an instance. But I could also say, take the class, get the method out, and apply it. And we saw that earlier on when we used other versions of classes to make that happen. We also saw, as we saw here, the idea of using a default value for a formal parameter. That equal sign says start off with having a default value for that name. And so, for example, in my animal case, I did that. I set the name to be something different, and that allows me to do that overriding of the default value here. Okay, let's see what we can do with those pieces when we get to the next section.